Okay, today we're going to talk about circular motion. Okay, we know that objects accelerate in three different ways. One is they speed up. The second one is they slow down. And the third one is they change direction. We also know that forces cause acceleration. Newton's second law says F net equals ma. Forces cause acceleration. Okay, so if you know that, an object in circular motion, say an object traveling around in a circle like this, let's say if we had an object on this thing, and it was traveling around in this circle, it'd be traveling a circular motion. And that object is changing direction the entire time it's traveling around in that circle. And because it's changing direction the entire time it's around in that circle, that object is always accelerating. And that acceleration is called centripetal acceleration. So if an object is always accelerating as it travels in a circle, then that means that there's always, since forces cause acceleration, that means there's always a force acting on the object to accelerate it. So there is always a force either pushing it or pulling it toward the center of the circle. That's the force, the centripetal force. And that centripetal force is accompanied by an acceleration, which also acts in the same direction as the force, and that's called the centripetal acceleration. Okay, so that's the basics. That's the basics of circular motion. So let's move on and talk about how you can apply those to some problems. So first off, if you have an object traveling in circular motion, and we're going to have the object out here. This is going to be this red thing, and it's moving around the circle like this. Okay? Turns out the speed of that object, s, is equal to the distance divided by the time. Okay? The distance around a circle, if you remember from like eighth grade math or something like that, is the circumference, c, and that's equal to pi times the diameter. Okay, it's also equal to twice pi times the radius, or 2 pi r. Okay, so the radius of this circle is right here, and that's r. Okay, and the circumference is the distance around the circle. Okay, so for this case, to calculate the speed of an object moving in circular motion, and this is an object which is moving in uniform circular motion, which means it's moving at a constant speed in a circle. It's moving at a constant speed. And we can calculate that by saying 2 pi r over the time. Okay? That time, a lot of times that time is called big T, and that's called the period. And that's the time it takes the object to travel in a circle. In one complete circle. Okay? Okay, so now we're going to look at doing a problem. And so we're going to take a problem where we have, takes a car going around a circular track. Track looks like this. The circular track. There's a car on this track. traveling around in circle like this. Okay? We're going to just say 30 seconds. That's the time, the period, to travel around that track. Okay? And that track it has a circumference of 15 meters. Okay? So what's the speed? Well, the speed is equal to the distance over the time, or circumference over the time. And that's equal to 15 meters divided by 30 seconds, or 0.5 meters per second. That's the speed. Okay? See how that would work? Okay. Now, if you know, for example, that the radius, I'll give you a second example here, and we have a car, okay, and we're going to have that car go around a circle with a radius equal to 15 meters. Okay? And we're going to have a time equal to 50 seconds to travel around that circle. Okay? So then in this case, the circumference is equal to 2 pi times 15, the radius, which is equal to 94.2 meters. Okay? The time, so the speed then is equal to the circumference over the time, which is equal to 94.2 divided by the time of 50 seconds. That's equal to 1.88 meters per second. Okay, that would be the average speed of that object going around a circle with a radius of 15 meters.